Okay, our next lesson here is section 6.4, graphing trig functions. We're going to start by graphing the sine function. So we have here, go ahead and pause the video and get this set up going, and then we'll get going. So we have y equals sine of x. Okay, so remember, x here is our independent variable, our domain, the input. For a trig function, the input is an angle. And almost 99% of the time when you graph a trig function, your angles will be in radians, not degrees. So, later in this lesson, you'll see why I have these values already set up on my graph. But for now, just go with it. And I'm going to pick nice angles for x that will give me values for y that are easy to graph on here. So let's go. Sine of 0 radians. Sine of 0 is 0. There's a point. And then let's go pi over 6. The sine of pi over 6 is 1/2. So let's go 1 here, -1 here, because we know that sine's range is everywhere from -1 to 1. So, and then here's pi over 2, so pi over 6 is about here. Pi over 6, 1/2. All right. Now, I'm not going to graph when x is pi over 4, because pi over 4 will give me a y value of radical 2 over 2. We'll see radical 2 is about 1.4 or something, and then divide by 2s we get 0.7, and then it's a little bit higher up, but I don't want to deal with those bad numbers. Pi over 3 is another special angle, but then we get radical 3 over 2. A little bit bigger, but not a good spot to graph. So let's just go to pi over 2. Okay, sine of pi over 2 is 1. All right. Next, let's go after pi over 2. Let's go 5 pi over 6. Because now the sine of 5 pi over 6 is 1/2. Okay. That should be a little bit higher. Okay, and then let's go sine of pi. Sine of pi is 0. Okay, sine is 0 at all multiples of pi, or it hits the x-axis at multiples of pi. 0, 1 pi, 2 pi, 3 pi, and so on. All right, after pi, let's go to 7 pi over 6. Sine of 7 pi over 6 is -1/2. Go about right there. Okay, and the next 3 pi over 2. Okay, sine of 3 pi over 2 is -1. Right here. Okay, ran out of room in my table, so I'm stopped making the table. After 3 pi over 2, let's see, that's 9 pi over 6. Let's go to 11 pi over 6. That's our next special value, 11 pi over 6, or a nice value. Okay, sine of 11 pi over 6 will be -1/2 again. And then lastly, sine of 2 pi will be back to 0. So here's our sine wave. This value should be higher. So what happens when you don't use graphing? Okay, but again, it should look like that shape. It should be a nice smooth curve. Okay, so that's what we call the parent function, the simplest type of sine. There's no transformations, no shifts. That's just sine of x. Okay, at the top here we have what we call our general form of a sine function. General form meaning it has all of the the basis for all the shifts, stretches, compressions, all that crazy stuff, how we change our graph. What we call transformations. So A is the amplitude. No, A is the coefficient of sine, so you multiply sine by. The amplitude would change how far up and how far down the graph is stretched. You can also change if the graph is reflected or not. Okay. B, the coefficient of x, the number you multiply x by, or the angle by, that will change the period. Period for sine is normally 2 pi, but if you change the period, we can figure out how long it will take to complete one cycle if you take 2 pi divided by b, or whatever that coefficient is. D is the horizontal shift, switching it left and right, and C is the vertical shift, shifting it up and down. Okay, today's lesson we're going to focus on just amplitude and period changes. So, first example we want to graph. We want to graph one cycle of y equals 3 sine x, or 3 times sine of x. Okay. One cycle meaning we're going to graph one period. Alright, so let's get our graph going here. Alright, when we graph trig functions, or at least sine and cosine, I use the 5-point method. 5 points. First, we're going to determine the period. Notice here, there is no coefficient for x, or the coefficient is 1. It's sine of 1 times x. So the period has not changed. It's still 2 pi. So I'm going to graph one cycle. That's going to go from 0 to 2 pi. So 0 is here. We'll say 2 pi is there. Okay. I'm going to cut that distance into 4 equal sections. So cut it in half to give me pi right there. Cut that distance in half to give me pi over 2. And then I need to cut this distance in half. Well, this is 1 pi over 2, 2 pi over 2. Here's 3 pi over 2. Okay. Next. I'm going to do this by transformation. So my final product, this function will be in black, but I'm going to graph first the parent function. I'm going to graph y equals just sine of x in green. That way we can see the other function and compare it. So sine. Sine always starts at 0, meaning sine of 0 radians is 0. So we start at 0. And then the max for sine is 1. The minimum, or then sine goes back to 0 at pi. The minimum for sine is -1. And then goes back to 0, and that's 1 period, or 1 cycle of pi. Or sorry, 1 cycle of sine. Okay, that is call it parent function. The one that we want to graph is 3 times sine of x. This is a amplitude change of 3, or a vertical vertical stretch of 3. The high points be stretched by 3, low points be stretched by a factor of 3. The middle points don't get stretched at all. So 0 does not get stretched at all, or you can think of 0 times 3 is still 0. When I say 0, I mean the y-coordinate. The y-coordinate here is 1. 1 times 3 is 3, so it's stretched up to 3. A y-coordinate of 0 times 3 is still 0. A y-coordinate of -1 times 3 becomes -3, or stretched down to -3. And here a y-coordinate of 0 stays at 0. Okay, so notice our amplitude of 3 makes the high points higher, the low points lower, but the middle points, what we call the midline, stays the same. Alright, there you go. Alright, our next example here, we're going to graph one cycle of y equals negative sine of 2x. So first thing I always do is check the period. Well, I have a change here. B is not 1 anymore. B is 2. Remember, B is the coefficient of x, 2 times x. So my period, calculate the new period length, is 2 pi, that's the normal period, divided by B, which is 2. Cancel, I get pi. Which means the period now is half as long, or it takes half the amount of time for the function to complete one cycle. Okay, so when I set up my period length, I start at 0, I'm going to end at pi, and I cut that distance into 4 equal sections. So halfway is pi over 2, half of that is pi over 4, and then this will be 3 pi over 4. Okay, I'm going to start by graphing in green here. In green, I'm going to graph y equals just sine of 2x. Okay, I'm still going to do the period change now, but I'm not going to do the negative here. I'm not going to do the reflection yet. So sine of 2x, sine starts at 0. Okay, the amplitude, or a, is 1, so the amplitude, the max is just going to be 1. Back to 0, down to negative 1, back to 0. Okay, now in black, the black is the function that we want. I'm going to graph same thing, except the negative here means everything's going to be reflected across the y-axis. So this point at 0 is reflected across, across the x-axis. Well, it's on the x-axis. Think of 0, the y-coordinate is 0 times negative 1 is still 0. Here, at this point, y-coordinate is 1 times negative 1 becomes negative 1. A y-coordinate of 0 times negative 1 is still 0. A y-coordinate of negative 1 times negative 1 becomes positive 1. And a y-coordinate of 0 times negative 1 is still 0. And this is the function that we wanted. Try to draw a nice smooth curve, as smooth as you can. And there. You can see that our black function here was just reflected across the x-axis from the green function. Okay? So that's by graphing by transformations. Alright, our last example here. We're going to graph 2 cycles this time of y equals 2 times sine of x over 2. So, I see, hey, something's happening here. B is not 1 anymore, it's something different. I'm going to check out what the period is. Period is 2 pi divided by b. B is not 2. Remember, this is, b is a number that you multiply times x. Right here we're dividing by 2 or multiplying by a half, so b is 1/2. 2 pi divided by 1/2 gives me 4 pi. So now the period is twice as long. It takes twice as much time for sine to complete one cycle, go up, down, and then back up. Okay, I want to graph 2 cycles, however. So let's get our graph set up here. Actually, no, let's do it back over there. Okay. This time I'm only going to do one graph. I'm not going to do transformations. We're going to do both the period change and the amplitude change at the same time. So, one cycle or one period now takes 4 pi. So let's go, let's put 4 pi right there. I need to cut this into 4 equal sections because that's one cycle of pi, or one cycle of sine. So here's 2 pi, pi, 3 pi, and then you need another cycle. So you need to go 5 pi, 6 pi, 7 pi, 8 pi. So the one period took 4 pi, well, 2 periods or 2 cycles will take 8 pi. Okay. Now, sine, I know, always starts at 0, or because sine of 0 radians is 0, and there's no vertical shifts going on here. So sine starts at 0. Okay, sine's normal maximum value is 1, but since my amplitude is 2, it's going to be twice as high. So now it goes up to 2, back to 0, down to negative 2 at 3 pi, back to 0, up to 2 pi, back to 0. Sorry, up to 2, back to 0, down to negative 2, back to 0, and that's going to be 2 cycles. We go up, down, back up, down, and back to the x-axis. And there, here's up, down, up. That's one cycle right there, and then there's the second cycle. Okay.